Hi, I'm Nicole Masters, and I'm an agroecologist. Imagine a few of you right now are going, what on earth is that? So I work with farmers, growers, and producers around the world looking at how can we work with natural systems to improve nutrient cycling, reduce inputs, and basically grow good quality food for you guys. So this is some of the people that I work with. I get them connected with soil. Why soil, you ask? When you talk to my family and ask them when I became first passionate about soil, my parents will tell a story of finding me as a toddler at the bottom of the garden, my little pinky picking out snails and eating them. My grandmother recalls we used to drive for long summer trips and we'd play I Spy. You guys familiar with I Spy? Now, I used to say, once I said, I spy with my little eye something beginning with E. And my nana is one of those kick-ass I Spy players, and she wasn't going to give up. But eventually she gave up. Apparently I was quite precocious, I don't know if you can imagine that at 6. I'm like, Nana, it's erosion. And I think I've had this lifetime of fascination with landscapes and what human beings have been doing and impacting on the planet. So when I first discovered soil, what surprised me the most was that, why aren't you all soil scientists? It's so exciting, really it is. When we're looking at what's happening in terms of greenhouse gas emissions, the quality of the food that we eat, and water health, it's all about soil. Yet, it's not common dinner conversation. It's underfoot, out of mind, out of sight, and really registers on policy at all. So yes, soil. So I'd like to just get a little bit comfortable for a minute, if I can. Yes. And I'd like to tell a tale. And like many a good story, it goes back to the beginning. So I'd like to take you back to Genesis and creation stories. And around the entire world, we have a story that we came from either soil, dirt, or clay. And it doesn't matter if it's the ancient Babylonians, Sumerians, Incas, Mayans, Indonesians, Asians. We have the story that connects us, that we came from the soil. And it's interesting, in New Zealand, our indigenous people, the Māori, have a story that the god Tane, who obviously predating internet dating, couldn't find himself a woman. So he took some clay and he began to roll it, and he made an effigy of himself with arms, legs, torso, important differences, breasts. Yes. And he made a woman. And to this, he took this woman that he rolled out of clay and he breathed into her. And he breathed life, and she came alive with a sneeze. Tihe mori ora. I sneeze and it is life. When we look at what science is now finding is that certain types of clay and the certain right types of chemical reactions in the right environment start to form RNA, the very beginning and building blocks of life itself. We come from clay. And when we look at the word human, it comes from the same root word as humus, the dark brown chocolatey substance that gives topsoil its life, as where we've come from. Now some of you will be going, clay, you're right. I came from outer space. So I'd like to introduce to you my friend the tardigrade. It's also known as the water bear or the water piglet. It's about 0.5 millimetre in size. This extremophile can survive down to minus 270 degrees centigrade and above boiling. It can survive what would be a lethal dose of radiation for us, about 1,000 times that. It can desiccate its body to 3% of the water in it. So you can imagine it shrivels itself up, and then it can survive like that for decades until someone applies a few drops of water and this creature will spring to life. So it's cryogenesis. It's the stuff that sci-fi movies are made of, yet this creature can do it. And so NASA scientists thought, well, that's all very interesting. Let's see if it will survive the vacuum of space. So it sent these tiny little creatures into outer space, brought them back, gave them a couple drops of water, and these things sprung to life. So they can survive in the vacuum of space. So in fact, when you're looking at the tardigrade, You may in fact be looking at alien life forms, and they walk below us, beside us. You'll find them in algae and moss. I encourage you to get a very simple student microscope and have a look at these things with your kids, because they're so extraordinary. So these organisms and organisms across the planet will live in every single environment, from the top of Mount Everest to the bottom of the deepest oceans, and right now, all over you. So imagine, right now, if you all disappeared, you would leave behind just an outline of your microbes, if we left just the microbes behind. All these microbes in your gut and on you right now. So we've evolved symbiotically with these bacteria since the very beginnings of time, side by side. And without these microbes, possibly you would die. You certainly wouldn't be living a very fulfilled life. And we actually look at how many cells are in your human body, and the latest research out of the human biome suggesting that we may have as much as 37 trillion cells in our body, but actually there's 100 trillion cells of bacteria in and on you right now. And this often comes to me. I have the fridge door open and I'm looking in there aimlessly when it occurs to me that perhaps it's not me that brought me to the fridge to find that bar of chocolate. It was the microbes, and I'm not responsible. Yeah. So we have these microbes around us all the time. And what doctors are now finding, and it's very, very, very interesting, and it ties in quite well with what the other speakers have said tonight, that we're now finding that microbes in your gut system have a relationship to autoimmune disorders. Type 1 diabetes, multiple sclerosis, leaky gut, arthritis, obesity, ADHD, anxiety, depression, aspirin, and more are being linked to these microbes that we have in our gut system. It's like an ecosystem, like the rainforest, imagine. So I'd like to take you back to that very first day that you were born. Now, try and remember it. It might be challenging. You might have screamed it out of memory. But imagine that we've gone from this highly sterile environment in the womb, and you're being squeezed down that birth canal. And this is the very first point of exposure to microbes. And as you come out of that birth canal, you better really hope that your midwife doesn't have a bad case of halitosis or strep throat, because if she breathes on you, she inoculates you with organisms that you carry for the rest of your life. So if you have recurring sore throats and glue ear, it's because of that very first exposure. So there's some researchers in Otago University who have developed a tablet that you can buy at a chemist and actually take that microbe, inoculate it in your throat, so that when your baby's born you can breathe good microbes on that child. Because it's those first 2 years of life that set up this whole system in our bodies. It's who breathes on you. It's, do you have cats and dogs at home? And most importantly, you're allowing your children to explore the natural world. Are they getting down and dirty in the soil? You see how much time children spend with their hands and their mouths? It's disgusting. Yeah? So what they're doing is inoculating themselves, and it's what sets them up for their entire immune system for their life. So scientists call this the farm effect, that children that grow up on farms often have better autoimmune system to actually protect themselves. So they've done some interesting research looking at what kind of gut microbes did we have only 2 or 3 generations ago. So this one particular organism, some research has been done on. About 80% of the American population had this organism in their gut in 1940. This organism is responsible for creating enzymes that are appetite suppressors. So this organism kicks in these enzymes after you've had a feed, so you don't feel hungry. Good organism to have? Yes. Now, only today, less than 6% of Americans have this organism in their gut. We're losing the diversity of these species, and some of these organisms are important and they come from the soil. It's about inhaling soil and about getting outdoors and getting exposed to different microbes. But what are we doing instead? We now have things like antibiotics, vaccinations, chemicals that weren't around before the 1940s. We have heavy metals, and we have this propensity for antibacterial soaps. Like being outdoors, climbing trees is somehow dirty and wrong. So I ask, are we cleaner? Or have we separated ourselves from a natural world that we're so symbiotically connected to that there's implications? Now I'd like you to just imagine for a minute your favourite smell. I'll give you 3 seconds. Yeah, you got it? My favourite smell is on a hot summer's day when you're driving in your car and you get a shower of rain that hits the road. You with me? That smell that you can smell is the excitement of an organism called actinomycetes throwing spores up into the air, basically reproduction. And the smell is called geosmin. Geosmin literally translates as the odour of the earth. So this beautiful smell that you can smell is made by actinomycetes. You may be familiar with them because you may have actually taken them as an antibiotic sometime during your life. So there's about 400 different antibiotics that are made from this soil organism. They're incredibly important in human history. And it's what gives soil its beautiful earthy smell, is these organisms. So it's antibiotics that you can breathe in. What scientists are also finding now is that breathing in soil organisms or being inoculated with them can lead to increased serotonin production. So you think serotonin is produced in about 90% of it in your gut system. That it can reduce anxiety and depression, and we can be gone with Prozac and go out and breathe some soil. So I want to take you back and just look at this big picture. So when we think about the steps forward that have come in human understandings of microbes, the same process is now happening in terms of what's going on in the soil. So if you can understand how it is that we digest food, so we chew it up, make it a bit smaller, it goes through your gastrointestinal system, getting smaller and smaller until it passes through into your bloodstream, right? That process is ameliorated basically by your microbes. Yeah, so they break it down, they have enzymes, vitamins, secondary metabolites, all that stuff that makes us healthy and well passes through that bloodstream. Now the same thing's happening in the soil, that we've got a process, and if we were to look at what's happening in terms of where that energy comes from, now what? That was confusing. Now, when we look at sunlight energy, this is what powers the entire planet, photosynthesis. So the very process of taking sunlight energy, that plant then takes it down through its root zones as a carbohydrate. So it's sugar. Carbon, hydrogen and oxygen is what that plant takes out of photosynthesis, sends it down through the root zone to feed microbes. So the plant can't send out for pizza, and it can't go down the road to the supermarket. So it basically has a currency that's sugar that it sends to its microbes and says, you know what, I feel like Mexican food tonight. Or I feel like Italian, and the pizza and this plant will actually dictate to the microbial community what it needs and when. Vitamins and enzymes. Now what's fascinating is the same process that we're doing to our own bodies in terms of antibiotics and chemical use, and maybe we're not taking soluble fertilisers, but the plants are, is disrupting this same natural cycle. So we're not getting the full vitamins and nutrients that we should be getting. And Ben Warren talked about it earlier on, that we're losing food quality, and up to 60% of the nutrients have been lost out of our food since 1940s. Now some of that might be due to genetics and breeding, but it's also because we're separating ourselves from this natural world and not treating soil like the living space that it is. So I'd like to draw your attention to this apple and imagine for just a minute that it represents planet Earth. And the skin on this apple represents the topsoil. So what I'm going to do is I'm going to cut this apple into 4. I'm going to cut it into 4 because 3/4 of the planet is in fact not topsoil. 3/4 of the planet is the seas. So you can imagine 1/4 of this planet is Earth. If we cut that in half, half represents land that we cannot grow food on because it's too steep, so thinking Antarctica, the Arctic, the top of the Himalayas, so land that we can't grow food on. I'm going to take the last 1/8 and I'm going to cut it into 4. And those of you with a really good mathematical brain will know that that is 1/32. So if I cut that 1/8 into 4, what this represents is, I'm going to take 3 parts of that. What it represents is land that we can't grow food on because it's too steep, too wet, too dry, too rocky, or it's already underneath cities and highways. So of all of this planet Earth that we see, to feed a burgeoning population of over 7 billion now, we have a soil resource, and I'm going to cut this off to represent our topsoil. We have a soil resource that's incredibly valuable, and it's the most vital of all of our resources on the planet, and we treat it like dirt. Thank you.